Hello everyone, this is the paper presentation of Group 8. Our topic is Customizable and Extensible Deployment for Mobile Cloud Applications. These are the authors and the presenters are Rajveer Sidhu and myself Zareen Khan. The main important topics that we are going to that we are going to cover in this as a part of this presentations are motivation, Sapphire, design architecture. Under design architecture, we are going to cover main important blocks that are deployment kernel and deployment managers, the programming model, implementation, experiments and evaluations, that is basically the performance. The performance we are going to compare across different platforms in terms of RPC latency, throughput comparison, scalability, and finally the conclusion. Let us discuss the main motivation behind this topic. Called the modern applications faces new challenges in managing today's highly distributed and heterogeneous environment. Somehow there is a need that programmers must stitch together code that spans over devices like smartphones, tablets, computers, and personal devices, and cloud, and make deployment decisions. In order to address these challenges, programmers must have to make some distributed deployment decisions like where exactly data and computation should be located, where data should be replicated or cached, what data consistency level is needed. It also depends on application requirements, and sometimes they have to mix application deployment decisions with complex application logic. Today's applications spread over many heterogeneous platforms and they have to communicate and share data. When it comes to simple application can actually communicate easily like using just a single common MySQL database. But for complex applications, it needs to use services like SOAP, REST, etc. to communicate shared data and logic. Sapphire is a platform which can actually integrate them and subsume most of their functions itself. Sapphire. The main topic that paper presents is Sapphire, a distributed and flexible platform. Sapphire actually facilitates the management and deployment of applications spanning over wide variety of devices like computers, mobiles, tablets, and cloud. Let us look at the architecture of Sapphire. It basically consists of three layers. As you see here, the top layer is the Sapphire application. The middle layer is the deployment management layer, which basically consists of deployment managers P, Q, R as shown in the figure. And the bottom layer is the deployment kernel DK. We will look at the details of these layers in the next upcoming slide. The bottom layer, which is actually Sapphire's deployment kernel layer, actually integrates the mobile devices with the cloud servers. Deployment layer. It is the middle layer, which is the deployment management layer that sits between the deployment kernel and the application. It is a collection of pluggable deployment management modules that extend the kernel to support application specific needs. Application layer, being the bottom layer, is actually where the application code resides. Sapphire objects. A Sapphire application actually consists of client side and server side applications. And these client side and server side applications are made up of Sapphire objects. The main important takeaway point for Sapphire object is that it shares common logical address so that each Sapphire object can invoke other through simple location independent calls. Let us look at deployment kernel in detail. The bottom layer is deployment kernel layer, which is flexible and extensible runtime system. It provides only the most basic distribution functions, including Sapphire object addressing and location tracking. Best effort RPC based communication. Sapphire object migration and basic resource management. The deployment kernel is actually a resemblance of IP service. Let's take a look at deployment manager in detail. The more complex functionality is provided by deployment layer with extensions to the deployment kernel called the deployment managers. So basically you can think of deployment managers as extended deployment kernel with more complex functionality. Each Sapphire object can have an attached deployment manager which provides runtime distribution. A programmer chooses deployment manager to customize behavior like, for example, in case of fault tolerance, with the help of a deployment manager, we can handle fault tolerance. Deployment managers, as pointed out earlier, customize and control the behavior of individual Sapphire objects in the distributed mobile cloud environment. The deployment kernel provide direct API support for the deployment manager. The deployment kernel does all the heavy lifting while the deployment manager simply tells the deployment kernel what to lift through the deployment kernel's API. There is also deployment manager library that provides for many management features. The below diagram is actually the deployment manager's structure and API. It basically consists of proxy, instance manager, and coordinator. Let's take a look at each of these components in detail. Proxy. The main responsibility of proxy is that for the caller side tasks like routing method calls. Instance managers. The main responsibility of instance manager is to take care of callee side tasks like, for example, keeping replicas of the Sapphire objects synchronized. Coordinator. The main responsibility of coordinator is for centralized tasks such as failure handling. All the components are optional. Programming model. This is an example of a Sapphire object from Bluebird. As you see, the Sapphire class user actually uses consistent caching. And as you see, the get username, get my followers, and these are the methods: get people follow, get my tweets, and so on. Sapphire has an object-based programming model. wherein Sapphire objects are key programming abstraction for managing application code and data locality. A programmer can define Sapphire objects using a Sapphire class declaration instead of standard class declaration as seen in sample code. Each Sapphire object will have its code and data on exact same virtual node. Calling Sapphire objects. Sapphire objects communicate using method invocation. Invocation is location independent and symmetric, means it can occur from mobile device to server, from server to device, from device to device, or between servers in cloud. Deployment managers help to handle failures on behalf of Sapphire objects. Sapphire objects are passed by reference, while all other arguments and return values from Sapphire object invocations are actually passed by value. Choosing deployment managers. Programmers employ the uses keyword to specify a DM when defining a Sapphire object. For example, in code snippet of Bluebird, the Sapphire class declaration binds the consistent caching deployment manager to the user class. In this case, every instance of user created by the program will have the consistent caching DM attached to it. As we can go back and see the code snippet, you will see that the Sapphire class user actually makes use of the keyword uses and binds the deployment manager consistent hashing to user. Sapphire provides a library of standard deployment managers. Additionally, deployment managers are extensible. Each Sapphire object can have only one deployment manager, and each instance of the Sapphire object must use the same deployment manager. Deployment managers API. The deployment kernel invokes deployment managers using up calls. Each component receives a different set of up calls, for example, on create, on RPC, etc. In each up call, the deployment manager component can perform various management tasks on the Sapphire objects using a set of primitives like invoke RPC, get node, etc. etc. Finally, the deployment kernel also instantiates one coordinator for each deployment manager instance. Deployment manager design examples. There are many classes of deployment manager design. The three of them are as follows. The first one is the code offloading, second is peer to peer, third is replication. The code offloading deployment managers are useful for computing intensive applications. Peer to peer actually supports the direct sharing of Sapphire objects across client mobile devices without needing to go through the cloud. Replication. The Sapphire library contains three replication deployment managers that replicates a Sapphire object across several servers for fault tolerance. Implementation. As you see this figure, the Sapphire application and runtime system. The authors have actually built the deployment kernel prototype using Java to support Android. Let's discuss the implementation. Altogether, deployment kernel consists of 12,735 lines, including 10,912 lines of Apache Harmony code. Java 1.6.0-38 Java Virtual Machine was used to run Sapphire in cluster, while tablets and phones ran Sapphire on Android. Java RMI was used for low-level RPCs between deployment kernel nodes. The prototype actually does not support secure communication between deployment kernel servers. Now, actually, these authors performed different experiments and have shared with us the evaluations of these their experiments in terms of performance. Authors describe their experience building new applications based on the following three objectives. The first one being development ease. It took relatively little time and programming experience to develop Sapphire applications. In particular, Deployment Manager library provides for most of these ease. They did not have to handle code failures because the code offload Deployment Manager hides them and manages itself. Even the largest application, Twitter clone Bluebird, was implemented in under 800 lines. Isn't that great? Now, the second point being deployment flexibility. The changing in Sapphire Objects Deployment Manager, which changes its distribution, requires only one line code change. Yes, that's correct. Just only one line code change to change its distribution. The authors made use of this very important property throughout their prototype developments. The third point being management code generality. Authors applied several deployment managers to multiple Sapphire objects within individual and across applications. With the Bluebird, which had 10 Sapphire objects, authors could reuse several of deployment managers. Let us see what kind of experimental setup the authors did. Actually, the experiments were performed on a homogeneous cluster of server machines and several types of devices like tablets and phones. Each server contained two quad-core Intel Xeon E5335 2 GHz CPUs with 8 GB DRAM running Ubuntu 12.04. The devices were Nexus tablets running on 1.3 GHz Hummingbird processor and 1 GB DRAM. Nexus S smartphones were with the 1 GHz single-core processor with 512 MB of DRAM. The devices were located on same local area networks as the server. Let us compare the performance in terms of RPC latency comparison. Authors compared Sapphire RPC to Java RMI and to REST and Thrift. While Thrift was generally faster in all cases, Java RMI and Sapphire were comparable and were faster than REST. Even Sapphire was faster than Rest without optimizations. RPC latency comparison table. Request latencies for local, server to server, tablet to server, server to tablet, and tablet to tablet. Note that REST does not support communication to tablets. As you will see, the last row for columns S to T and T to T are dashed out for REST. That means it doesn't support communication to tablets. Let us compare the latencies for each of these four platforms in case of local. You will see that the latency for Sapphire is 0.08, which is comparable with the Java RMI, which is 0.05 and 0.04 for Thrift. But it is way faster as compared to REST. The latency for REST is 0.49. In case of server to server, again in this case also, the Sapphire is 0.16. The latency for Java RMI is 0.12 and for Thrift it's 0.11. And for REST it is 0.64. So again, Sapphire latency is comparable to Java RMI and Thrift, but much faster than REST. And same for server to tablet and tablet to tablet. Now, let us distinguish the performance for all these platforms in terms of throughput comparison. Authors measured throughput for Sapphire development kernel and deployment kernel and Java RMI. Java RMI's object throughput was 15% higher. This is because Sapphire's null RPCs are not truly empty. They carry the serialized structure telling deployment kernel how to direct the call. To break the cost further, authors compared again with Java RMI carrying some dummy payload, identical to Sapphire's null RPCs. It reduced the difference to 3.6%, which is a significant difference from 15% to 3.6%. This additional cost is the serialization cost for dispatching structure. This is a chart of throughput comparison between Sapphire development deployment kernel and Java RMI. As you will see, x-axis are the number of clients and the y-axis is actually the throughput. The red graph is for Java RMI null RPC and the green graph is for Sapphire null RPC. You will see that the graph is linear for Java RMI until around about 105K and then it enters the saturation region. And for Sapphire null RPC, which is the green graph, you will see that it is linear. The graph is linear for about 40 clients and let's say 90K throughput. And then the graph enters its saturation region. Let us compare the Sapphire deployment kernel operation cost. In this experiment, authors measured the latency of several deployment kernel services. Deployment kernel call latency depends on size and complexity of the object. Since Java serialization is used in Sapphire, The Sapphire object instantiation can be expensive because the deployment kernel must create several objects locally, like the Sapphire object, the Sapphire object stub, the deployment manager proxy, and the deployment manager instance manager. Let us discuss performance of deployment manager in terms of scalability. Authors built the load balancer front end deployment manager to scale a stateless Sapphire object under heavy load. The deployment manager creates a given number of non-consistent replicas of an Sapphire object and assigns clients to replicas in round-robin fashion. The chart on next slide for scalability effect shows the throughput of the Sapphire object serving null RPCs when the deployment manager creates up to 3 replicas. Throughput scaled linearly with the number of replicas until the network saturated at 257,365 requests per second. The diagram shown here is actually the scalability chart for deployment manager performance. Shows the effects of applying the load balanced front-end deployment manager. The red graph is for one node, the green graph for two nodes, and the blue graph for three nodes. As you will see that the graph remains linear for three nodes. There is a blue graph for about range of 250,000, near about 250,000 plus something, and then it enters into the saturation region for three nodes. And with this, I would like to conclude our topics. So the main takeaway points to conclude is Sapphire simplifies the development of mobile cloud applications. Sapphire greatly eases the programming of heterogeneous distributed cloud mobile applications. It provides great flexibility in choosing and changing deployment decisions. It gives programmers fine grained control over performance, availability, and scalability. I would like to thank you all for your time. Thank you, take care, and bye bye.